Hello everyone. Today in this video clip I'm going to go over the very last two sections of our course, section 8.5 and section 8.6. In 8.5 I'm going to introduce you a new thing called the polar equations, and then on 8.6 we'll talk about parametric equations, and of course I will show you the graph of those. Alright, so let's start with the polar equation on 8.5. So polar equation. Before, whenever you want to represent a point on the line, we're going to use something called the Cartesian coordinates or rectangular coordinates. I would say a point P will be represented by two coordinates, x and y. Okay? So x, so the x-axis tell you how far it is from the x, right? And y will tell you the distance from the origin to the point on the y-axis. Okay? So how high it is and how far it is. Okay, and this is a point P. Okay, and this is not the only way to locate a point on the plane. There is another way, at least another way, to find a point P. So instead of use two coordinates x and y, we can find a point P using the distance r, instead for radius, the distance from the origin, and the angle it makes to the polar axis or the x-axis, the angle theta. So the point P can be plotted on the plane using r and theta. Okay, let me give you an example. Say, so now I don't need x-axis, y-axis anymore. I only need one axis, or the x-axis or the polar axis would be good enough. Say if you got a point P of 2 comma pi over 4. And you know that pi over 4 means 45 degrees, right? And 2 is the radius 2. So the angle of 45 degrees. This is 45 degrees. So theta right here is pi over 4, 45 degrees. And from the origin, this is 2 units. So point P right here, 2 comma pi over 4. So point so on. Okay. So at first we're thinking of the positive distance and positive angle, and of course later on you can extend the concept to negative angle. So what if I give you the second point, say point Q of 2 comma negative pi over 4. Instead of going counterclockwise going up, you have the angle of pi over 4. So you go this way. You're going to have the angle of negative pi over 4. And from origin, you measure distance of 2 units, right? So this is Q. Right. 2, 1, 2, and then the angle of negative pi over 4. So 2 ways at least. What about, how about the point 1 comma pi over 2? Okay. Let me erase this, have more room to write. And pi over 2 means 90 degrees, so it's going to be this way, and this and 1 is right here, so this is point 1 and pi over 2. Okay. How about 3 comma pi? Pi is the angle of 180 degrees, right? And 3, 1, 2, 3. So this is a point. Okay. And just introduce you another way to represent a point for the polar coordinate, right? So we have r and theta instead of x and y. All right. Now let's show you an equation. What if I give you an equation? How about this one? R is equal to 1. You know what this is? This is the equation of a circle of radius 1. Okay? The R is 1, theta could be anything. What if I give you the equation theta equal to pi over 3? Means what? All the point got any distance from the origin as you want, but the angle is pi over 3. This is going to be a line. Pi over 3 means 60 degrees. This is the line right here. Equation of theta equal to pi over 3, right? And the circle right here is r equal to 1. Okay? And those are equations in terms of polar coordinate. And let me just try to show you some more equations. Let me just copy from the book. See, you can have beautiful pictures with the polar equations. And you guys can draw them using calculators. All right? Let me just show you one. I found a good one. How about this equation? Use red color, okay? R is equal to 1 plus cosine theta. And look, the picture is going to look like this. Okay, looks like a heart. Okay. This one is for R is equal to 1 plus cosine theta. So how do you kind of roughly sketch a graph of the equation if you are given the equation? Just like the xy coordinate hints, you try to make a table, right? Theta and then r right here. Say for example, this one right here. You plug in some value for theta and you calculate r. Say theta equal to 0, plug in what? Cosine of 0 is 1, right? 1 plus 1 is 2. So this is a point right here. This is 2 right here. This is 1 right here, right? When the angle is 0, then the radius is 2. What if theta is equal to, say, pi over 4, for example? Pi over 4 is 45 degrees. Cosine of 45 degrees is root 2 over 2. 1 is 2 over 2. So 2 plus root 2 over 2. You see, we have another point. Pi over 4 is the angle right here. This is a point. If the angle is 45 degrees, then the radius is 2 plus root 2 over 2. So forth and so on. Try one more. Say theta equal to pi over 2, for example. Pi over 2, cosine of pi over 2 is 0. 0 plus 1 is 1. What's right here? 1. Right, angle is pi over 2, 90 degrees. The point is, the angle is 90 degrees. The distance is 1 unit. So forth and so on. You have a lot of points, and then the more points you have, then the finer the graph will be. You connect them all. Okay? That is about polar equations. Okay? We start with a point, many points, and give you an equation. Okay? The next question is how to convert back and forth between the rectangular coordinates and the polar coordinates. So this is important. And when you guys watch the video, I